Right, multiplying and dividing radicals. Okay, so this is probably going to be just a quick run through. Root 3 times root 3 is root 9, which will take you back to 3. Okay, and I think I mentioned this in some earlier videos. Root 3 times root 3 is like saying this. What's root 3? All squared. And it's kind of like the square root and the square kind of cancel each other in some ways. You can think of it like that, and you've just got the 3 left. Okay, but look at the actual work there. Now this one, I mean 32 times 50 is 1600. Calculators for this, the square root of 1600 is 40. But it may be that you don't just do it like that, and you do it like this. In other words, try and simplify those square roots first. So remember, I've kind of shown you how to do these. 32 is 16 times 2. Okay, you can write it under a single square root if you want to. Okay, like that. 16 times 2. Okay. Okay, we also have a 50, which is 25 times 2. Okay. So can you see from this? If I just erase that there, root 16 is 4. I've still got a root 2. So that is the simplified version of the root of 32. Root 50 becomes 5 root 2. Now you can multiply these two together. 4 times the 5 makes 20. Now go back and look at that first rule here. What's root 2 times root 2? It's going to just be 2. That also is 40. Okay, so it seems like more work, but supposing you didn't have a calculator, you weren't sure, you can break these square roots down into simpler things and then multiply them. So I'm just going to run through some of these. Just word through this. Something like question 6. Because they're both cube roots, you can put it into one big cube root if you want to. And say, right, what's 3 times 25? It's 75. What's x squared? There's nothing too much to do with this one. That's pretty much it. I can't really cube root 75. I can cube root 125. So not too sure about that one. Now let's have a look at some of the next ones. Look at question 7. Okay, I'll put a star next to it because I'm going to scroll down and look at question 11. Okay, this one here. Now notice they're really just two numbers, one on top of the other, but either written under one single square root or two separate ones. It doesn't really matter. So if I go back up here, supposing I did this, wrote it as question 11. I've got a root 48 and I've got a root 49. I think sometimes it's just knowing whether to combine into a single root, whether it's multiplication or division, or just leave it as two separate ones. Because of course the square root of 49 is 7. Okay? The square root of 48 is the square root of a 16 times the square root of a 3. So the final answer for that is 4. That's the square root of 16. Still got a root 3. Now got a nice 7 on the bottom. Okay, and that's it. Now be aware that if you can, look at these two numbers here, the 4 and the 7, and if you can reduce it, you can do. If it's 4 over 8, that would reduce to 1 over 2, like 4/8 is 1/2. But that's okay for that one. So if I jump down to this one, what they're saying here is okay, the square root of 144 is 12, root 45 is root 9 times root 5. Okay, so the square root of 9, oh, this one's going to work. The square root of 9 is 3, root 5. So this one will do that little reducing. There's the 12. So there we go. Now look at this. I can do this. That's 1 over 4. And there's still the root 5. Horrible root, but there you go. All right. I don't really need the 1 there if I don't want to. It's root 5 over 4. So there's some basic ones just with numbers. And I'll just stop there, do another one for more complicated ones.